students. Today we're going to look at finding inverse or verifying the inverse through composition of functions. You looked at a Jamboard earlier and you had where you looked at the definition of composition, and it means to put things together. In fact, let's look at that. There it is. The word composition, I copied there the first definition that says the act of combining parts or elements to form a whole. That's what we're going to do with these functions. We're going to take f of x and g of x. We're going to combine them, combine those parts or elements, and then we're going to use that to verify, are those two functions, are they inverses or not? Okay, let me go back. Where did that little tab go? It went away. Okay. All right, let's do this. When we talked about functions, we used the notation f of x and g of x. And we talked about if we had f of x, let's say if we had f of x equals 2x minus 4, and to find f of 3, then we would take this number that's in parentheses and we put it in place of this x. So we'd have 2 times 3 minus 4. 2 times 3 is 6. 6 minus 4 is 2. So f of 3 is 2. We know that in that function where x is 3, the y is 2. If we looked at the graph where x is 3, the y would be 2. If we looked at the table where x is 3, y would be 2. How did we use that notation? We took what was in parentheses and we plugged it in for the x. The same would be true for this g of x. Let's say if we had g of x equals negative 3x, and I wanted to find g of 12. Then I would take what's in the parentheses and replace this x with it. So it'd be 3 times, or negative 3 times 12, which is negative 36. So g of 12 would be negative 36. That means for that function, where the x is 12, the y is negative 36. Whether you're looking at the table or the graph or an equation, if you plug in 12 into the equation, that's what we did. We got 36. Okay, so today we're taking that a little bit further. And we're going to look, let's say we have f of x equals 3x minus 5. Look where I had it written down. And g of x equals 1/3 x plus 5/3. And I want to know, are these inverse functions? The question might say, verify that f of x and g of x are inverse functions. Or the question might say, are f of x and g of x inverses? To find that out, we're going to use a process called composition of functions. And we're going to find f of g of x. And we're going to find g of f of x. It looks like fog and golf, but it's f of g, g of f. Another way to write that is this. Means the same thing. Oops. Okay. It's two different ways of saying the same thing. So what we're going to do, we're going to look at what is in the parentheses. G of x. Instead of a number, we have the entire function. So I'm going to look for g of x is this, right? 1/3 x plus 5/3. I'm going to replace this x in 3x minus 5 with that entire function g of x. So we have 3. Replace the x with 1/3 x plus 5/3. And then minus 5. Draw a line here to keep that separate. Okay, now what can we do with this? We can distribute. 3 times 1/3 is 1. And 3 times 5/3 is 5. And we have this minus 5 on the outside. What else can we do? We can do 5 minus 5, right? Those 5's cancel out. And what's left is x. That's going to be important for us today. It won't always be just x. Not everything will always cancel out. But that's what we're going to be watching for to see if these are inverses. If they're inverses, both sides of this are going to cancel out to just the x. If either side has anything left besides the x, then these two functions are not inverses. So that's what we're watching for to see if everything cancels out. Okay, let's move to the other side. We did f of g of x. Now we're going to do g of f of x. So start inside the parentheses here and you have f of x. What is f of x? F of x is 3x minus 5. Remember with the numbers, we took what was in the parentheses, we plugged it into the function. That's what we're going to do here, but instead of a number inside the parentheses, we have f of x, which is 3x minus 5. So take 3x minus 5 and plug it in for this x. So we have 1/3 in place of the x, 3x minus 5 plus 5/3. Plus 5/3 came from here. Okay? What have we done? We took the entire function f of x and we plugged it into g of x. We're composing those two functions. What is f of g of x? I'm sorry, this side is g of f of x. Now, distribute. 1/3 times 3 is 1. 1/3 times -5 is -5/3. Bring down your plus 5/3. What happens? These cancel. What's left is x. Because f of g of x equals x and g of f of x equals x, then these are inverses. So f of x and g of x are inverses, are inverse functions. You'll see it written both ways. Okay, composition of functions. You're plugging one into the other. Let's try another one. Okay, let's look at this one. F of x is 3x plus 6. Let's change color here. Keep it a little more organized. G of x is 1/3. No, yeah, 1/3 x minus 2. And if my question asks me, are these inverses? Or it says to verify these are inverses by using composition of functions. Then I'm going to take and do f of g of x start with this g of x, which is 1/3 x minus 2, plug it into the function f. So it's 3 times 1/3 x minus 2 plus 6. Uh-oh. Sometimes people forget to bring this down after they've replaced the x. Now, distribute. 3 times 1/3 is 1. 3 times -2 is -6 plus 6. We didn't distribute there because the parentheses stopped. What happens to the 6's? They cancel. So f of g of x is x. Okay. So now we move to the other side. And we're going to check g of f of x. Started here. F of x is 3x plus 6. Plug it in right here. So you have 1/3. Replace that x with 3x plus 6. And then bring down your minus 2. What have we done? We took the entire function f of x and plugged it into g of x. What are we looking for? We're looking to see if everything but the x cancels. What's 1/3 times 3? 1/3 times 3 is 1. 1/3 times 6 is 2. Bring down the minus 2. What happens to the 2's? They cancel. So g of f of x equals x. Since both of these worked, or both of these canceled everything but the x, then yes, these are inverses. Okay. So if you have two functions, you're trying to verify inverse, you plug g into f and f into g, and check to see if everything cancels out to just x. Okay. Let's look at another one. We have f of x equals 1/2 x plus 4, and g of x equals 2x minus 3. Okay. To see if these are inverses, I'm going to do over here f of g of x, which means I'm going to start with g of x and plug it in right here for this x. 1/2, replace the x with 2x minus 3, add the 4. You with me? You see where the 2x minus 3 went? Now distribute half of 2. 1/2 times negative 3 is minus 3/2 plus 4. What do you notice? Does everything cancel? A negative 3/2 and a positive 4 don't cancel. So not everything cancels out. This would be, 4 is 8/2. So that would be x plus 5/2. Now, we're not working it out to see what, all we're looking for is does everything cancel but the x? Because we're trying to verify if these two functions are inverses. So in this case, f and g are not inverses. And we know that because this didn't cancel. We don't even have to do the other side. Because for them to be inverses, both sides must work. So as long as you've done this one correctly, and they didn't cancel out, then you're finished. Okay? Let's try another one. What if we had f of x equals 2x plus, no, 1/2 x plus 4, and g of x equals 2x minus 8. Now, let's see what happens. If over here I have f, let's write, and this, remember this means the same thing, whether it's the little dot or whether it's the two sets of parentheses. Start with g of x. Plug 2x minus 8 in here. So I have 1/2 times 2x minus 8 plus 4. Distribute. Half of 2 is 1, half of 8 is 4. And what do you notice? The 4's cancel, and all you're left with is x. Move to the other side. And now we're going to look, because they both have to cancel out, right? Not just one side, but both. So now we have g of f of x. So start with f of x, which is 1/2 x plus 4, and plug it into g. 2, replace the x with 1/2 x plus 4, bring down your minus 8. Distribute. 2 times 1/2 is 1. 2 times 4 is 8. Bring down your minus 8. What happens? The 8's cancel, and all you're left with is x. So are these two functions inverses? Yes. F of x and g of x are inverses. How do we know? Because both sides canceled out to just the x. Okay? Let's try one that looks a little bit more complex. So again, these directions would read something like this. Verify that f of x and g of x are inverse functions. These are what your directions will look like when you plug f into g, g into f. It doesn't matter what order. You can plug g in first, you can plug f in first, it doesn't matter. Okay, so let's try this one. F of x equals negative 16 plus x divided by 4. G of x equals 4x plus 16. Don't let the fractions scare you off. Okay, we're going to do the same process. We're going to find f of g of x start inside the parentheses, g of x 4x plus 16, plug it in right here. So I have negative 16 plus 4x plus 16 over 4. Follow? Okay, this 4x plus 16 is from g of x. Now look at the top part of this fraction. What happens to a minus 16 and a plus 16? You're right, they cancel. What about 4x divided by 4? The 4's cancel. What's left? What's left is x. Okay, so f of g of x is x. Now what do we need to do? We need to check the other side. So now we're going to do g of f of x. Start inside the parentheses. F of x is this whole fraction. We're going to plug that whole fraction in here where this x is. So I have 4. In place of the x, we're going to put negative 16 plus x divided by 4. So do you see that? There's your 4x. 4, replace the x with this, and plus 16. Now, I know it looks ugly, it looks a little complicated, but all we're doing is seeing if things cancel. Do you see something that can cancel? I see a negative, or I see a 4 and a 4. So multiply by 4 and then divide by 4, right? This 4's on the top, this 4's on the bottom. They can cancel. Now what do I have? Negative 16 plus x plus 16. What happens to the 16s? Minus 16 plus 16 cancels. What's left? Just this little x all by himself. So g of f of x equals x. So are these two functions inverses? Yes, they are. How do we know? Because we plugged g into f, and we plugged f into g, and everything canceled but the x. All right, let's try another one. What about this one? F of x equals negative 4 sevenths x minus 16 sevenths. I know, ugly fractions, but it's okay. You're in algebra 2, you can handle it. G of x equals 3/2 x minus 3/2. Now, what are we going to do? We're going to come over here and we're going to do f of g of x. Start inside the parentheses, take this, plug it in here. So I have negative 4 sevenths times 3/2 x, don't panic, minus 3/2 minus 16 over 7. Do we need to calculate all of this? Not really, because is it going to cancel everything out? There's nothing to cancel out with the negative 4 sevenths. If we multiply that by 3/2, we're going to get 12/14. There's nothing to cancel that out with. There's nothing to cancel with the 16/7. There's nothing to cancel with 3/2. It doesn't cancel. So you know what? These are not inverses. F of x and g of x are not inverses. Do I even have to mess with the other side? No. Sometimes one side will work and the other side won't. But as soon as you have one that doesn't work, as long as you've done your math correctly, you don't have to do the other side because they have to both cancel to be inverses. All right, let's not end on an ugly, ugly one. Let's try one more. What about this one? F of x equals -2 over x plus 1. G of x equals, lost my place, -2 over x minus 1. Okay, still some ugly fractions, but you know, fractions just divide. So first let's do f of x, f of g of x. Which means we're going to take g of x, which is this, plug it in for this. So we have -2 over x minus 1 plus 1. Okay, this replaces this x. This plus 1 came from right here. Now, what are we looking for? We're looking to see what cancels. Look in the bottom of that big old fraction. You see that -1 plus 1? So those cancel. Now what we have is -2 divided by -2 over x. Think back when you learned to divide fractions. You learned keep, change, flip. Keep the -2, change divide to multiply, flip this. What happens to those 2's, those -2's? They cancel. What's left? Just the x. Okay? Which means now we need to check the other side. You almost wish it had not canceled, right? All right, so let's check this side. Now we need to do g of f of x, which means we're going to start inside the parentheses and take this, which was 2 over x plus 1, -2 over x plus 1, and plug it in here. So start with this -2 on the top, replace the x with -2 over x plus 1, and then a minus 1. Okay, this is a divide, right? This part is a divide. So -2 divided by -2 over x plus 1. Keep, change, flip. Then we have this minus 1 out here. These cancel. Can you see that little purple? We have x plus 1 minus 1. What happens to the 1's? They cancel, and all we have left is x. So those are inverses. That is the process of verifying inverse by composition of functions. Now there are other ways. You could graph the two functions and see if they reflect over the y equals x. You could write the equation of the inverse like we learned to do, switch the x and y, solve for y, and see if they match that way. But one of the requirements in Algebra 2 is that you learn how to use composition of functions. When you go past Algebra 2, you'll do some more work with composition of functions. But this is a way you verify inverses. Okay? Have a good one.